All right, we're given some information here. It says a sample of 30 observations. I tend to start doing this. N, which is my sample size, is 30. Make that a little bigger so you can see it. And then from a normal population, which tells me I can use my Z. That right there tells me the normal population right there says that I can use my Z formula. And then it says where the sample mean, well, the sample mean is X bar, not BART, is 21. And then the population standard deviation, which would be sigma, is 6. And it says conduct the following test, and we are given an alpha of 0.05. And so what we want to do here is we want to figure out, and if you remember that a standard normal, if I can find my pencil, a standard normal, we want to standardize this to a mean of 0. What does this mean right now? 20. And we might want to put that over here too. I clicked the wrong thing. Where was I? Draw. Okay. And mu is 20. This is always in our hypothesis. Okay. So we can see 20. We went out and we got a sample that was at 21. And what we want to do is figure out, is there statistical significance based on, is this too far away? Notice this is a right tail test. So ultimately we're going to be looking at this area right here, which that area right there is called a p-value, that we're going to be looking for the probability. Now they tell us where we're going to cut this off is at 0.05. We don't really know where that is yet, but we could find that. So we could find our critical value, so Z critical value, because this is a right tail, so norm.s.inb, the probability that we would put in is 1 minus this value. Remember that when you're looking at probabilities, it's always everything to the left. And so what this would be, and we could round this to 2 decimal places, this would be my critical value. So what we want to do is figure out where that critical value is here based on my sample. Well, how do we do that? Well, we take the Z. Let's do U right here. So this is my Z test statistic. And I find this by equals, oops, that can't see it anymore. Let me put it right there so you can see it. I find it by equals, notice I open a parentheses, the sample mean minus, did I do something? Minus the population mean divided by, be sure and put the bottom in parentheses, the standard population standard deviation over the square root SQRT of the sample size. So if you look at this, I've just, referenced these cells. I always reference cells so I can reuse this for different numbers. I'm doing this formula right here. So 21 minus 20 divided by 6 over the square root of 30. When I hit enter, I get this value. Now this is important. And again, we'll put everything in terms of 2 decimals. The reason why this is important is this is saying, so that's 0. This is saying this test statistic is right here. When we would reject, we're way out here, right? The 1.65. This would be our rejection region. So we already know we are not going to reject. We failed to reject the null, but we can also find the p-value. What the p-value is the probability that you would expect to get 21 based on the mean of 20. And we can do that with equals norm.s.dist. There's so many formulas. And I'm going to use these 2 digits here and 0.91. Okay, so this gives me the probability I would expect to get this value. Oops, I forgot to put at the end. See, even teachers make mistakes. You need to say true. All true means is to add up all the probabilities. But there's a problem. This isn't the real probability. Why isn't this the real probability? Because what this is actually given us is this probability to the left. So that's this value, 81859. Why? Because that's just how the tables work. They go from the left all the way up to that value. We want this side over here. Well, that's pretty easy to get. You know, all probabilities add to 1. So this would equal 1 minus this value. And therefore, we would say the probability we would expect to get 21 if the true mean is 20 is about 18%. This is certainly higher than you compare this to alpha versus 0.05. If the probability is greater than your level of significance, which is alpha, then you fail to reject as well.